TSIO. TS-100, not TSIO. So we got past signal edge detector, although that was hard work. So let's go to interrupt handler. See how that grabs us. Oh, I need to turn desktop volume on, which means that you might get the occasional Discord alert and so on, but you'll just have to put up with that. Desktop audio, there we go. Keep it relatively low. Okay. Now, read from N1 through N4. 1, 2, 3, 4, fair enough. Write the input number when the value goes from 0 to 1. 2 interrupts will never change in the same interrupt cycle. Huh. Okay. What does our debug text say this time? My sister was over for the holidays. I think to check on me. Make sure I haven't gone off the deep end. I know I caused some worry. Her kids saw me working here and suggested I could surf the web for TIS-100 specs. So even kids are on about internet, online, blah, blah, blah. It's a racket. I don't care about the information superhighway and I never will. Oh, Randy, you were such a Luddite. Sitting in his garage playing with his TIS-100. All right. 2 interrupts will never change in the same input cycle. Write the input number when the value goes from 0 to 1. So for example, in this case, N4 is the interrupt, so we should output 4. Cool. All right. So we need to disambiguate two of them will never change in the same input cycle. So when 1 is true, I see, only output it when it goes from 0 to 1. Oh, tricky. So you have to store the previous one. That goes without saying. And you can rely on the fact that only one of them is going to change at a time. Okay, cool. So I guess the first thing is to read to ACC for all of them. And save. Okay. Now, how should I indicate I think all I need to do, this could easily be an oversimplification, but let's go jump equal to 0, skip or continue. Otherwise, if it's a 1, then we need to go jump check. No, we don't. We can just stay right here and do it. So we know it's not a 0. is the current state. So that means we can sorry, just checking a message. Okay. So in this case, we can swap so that the number in back is now an ACC. And we can go, we know now that the value in ACC was 1. So if jump greater than 0, actually no, jump equal to 0, output. Output is going to be move 1 down. JMP begin. Begin. So the reason we want to do this here is because we're checking the previous value. The previous value was 0. Then we jump here. Otherwise, we jump begin. Actually, there's no reason why we couldn't do this. Right? So we know for a fact that if it's equal to 0, just ignore things. Otherwise, swap and check the previous value. So at this point, we know that the input value was 1, and we want to know if the previous input value was also 1. If the previous input value was 0, then we jump to out, and we move 1 down, because 1 is the number of the input aisle. And then this becomes move up, right, move left, down. Oh, we got to be careful here because we've also got to deal with the, shoot. This should be move any right. This should be move any down. This should be move any down. Move any right, left. Okay. I have no idea if I've captured what I need to here, but let's try it. And then this is 3. This is 2. And this is 4. Yeah, let's step through that. I have no idea what I'm doing. Okay, so we should be getting a 4 out soon, but it doesn't look like we are. Yeah, we're getting no output whatsoever. Okay, I've screwed something up. What have I screwed up? The first case is supposed to be 4. So let's advance that to when we get that 1. There's the 1. We save it. Oh. Yeah, that won't work. We got to save it later. We have to save it later. Yeah, otherwise we're just always overriding it. Okay, cool. So move the 1 into ACC and we've got a 0. You can't save it. So that's definitely wrong. JEZ begin. We still need to save the previous value, but we need to do it. JEZ next. Next is save. JMP begin. Yeah. Then swap JEZ out. And then out needs to be save. Move 1 down. I think that might be better. Actually, hang on, what about this case? What if both of them are false? You still need to save. So actually you can just let it fall through to next, because that'll save and then jump to begin. In which case, yeah, that's right. I mean, you could put the save in, yeah. Excuse me. Yeah, I don't know. Let's try this. Two, 3, 4. All right, let's get to the point where we see that first one in column 4. There it is. Okay, so we've got 1 in ACC. JEZ is going to fail. We swap. JEZ out. So we now save, which is wrong, because we've swapped. So swap has the same effect as saving. All right, cool. So that's wrong as well. So this is JMP begin. Oh, I see. We need to avoid swapping if it's a 0. We don't have to, do we? Oh, yeah, I suppose we do, because we don't want to write 0. Wait, hang on. If it's a 1 and then we swap, if it's a 1 and then we swap, as long as we always swap, I think that's okay. No, it's not, because what if it's a 0? So we need JEZ. We need JEZ skip. Actually, let's just call it 0. Save. And jump begin. Otherwise, we've swapped, so we don't need the final save in either of the above two cases. It's a bit repetitive, this bit. There we go. Okay. Once again, we'll just step through to the point where we've got the 1. There it is. JEZ0 will fail. Swap. JEZ out. Move 4 down. Excuse me. Oh, I'm not writing the zeros. I've got to write the zeros. Damn. Shoot, this makes it a lot more complicated. Yeah, I should have known that. I should have known this was far too simple. So they all need to arrive at the same time. Do I need to count them? Like, do I need to count and see if I get 4 values? Or is this not, is that too complicated? So 0 is, hang on, let's name these better. 0 is save. Mov 0 down, jump again. And we'll just call this 1. I could use Vim keys. Okay. So now we get 0 or 1. And they're all going to funnel into here. Which one's going to happen the fastest? This one has to happen. I mean, should we make it so that they all arrive at the same time? Should I attempt to count them and only forward when I get 4? That feels fragile. How do I decide whether or not to output a 0? I could combine the 2 streams. So I could combine these 2 and these 2 and essentially XOR them. And then combine them again here and here and output. Is it that complicated, or am I overthinking it? I want to see how fast these values arrive at their next destination. Okay. 0. So they all get moved down at the same time. And we've got 1 there, one there, and one there. I think I need to combine them both. I need to combine both streams on either side. How else could I do it? I could... How else could I do it? The only other approach I can think of is to output only after I've counted 4 of them. So I'd have to count to ensure that I got 1 from each column. And then only then output a value. I think I'll go with the combining approach first and see where that leads me. So in this case, we want to do it here. And we're not just going to move any right. We're going to go... first of all, if we know... If we get a 2, or if we get greater than 0... So read, hang on, mov up ACC, JEZ left, and left will be mov left down. Otherwise, mov ACC down. Jump begin. Okay. That just always mobs up right. So that combines those 2 values. Yeah. Okay, cool. So let's do it again here. Move up ACC, JEZ R for right. Move ACC down. Otherwise, move right down. Yeah. And then we've got 1 of 2 possible correct values. So begin, actually this is exactly the same thing. Except that we're on the left. Mov up right. Okay, let's give that a quick run. Okay, so it failed. Whoa, okay. So it starts all right, but it fails. All right. So we get a 4. We get a 3. Looks like number 4 is processing and the others are blocked. What's going on there? Oh, it's because this is blocked. Right, so we need to dispose of the values that we're not using. That's what's going on. So if we don't use the value on the left, mov ACC down and mov left ACC. In effect, getting rid of it. Mov right ACC. And this one is mov left ACC. Nope. Similar problem, maybe? Oh, I wish it would. There we go. So yeah, similar problem. We've got mov upright, can't do that. Mov up ACC, but it's not available. Oh, look at that. That was the value that it was supposed to pick up. That's weird. Why did it do that? I would have thought. So at 3, let's progress through to 3. We'll go put a breakpoint in here. So all nicely in sync here. Oh, it didn't even hit until ages away. So why does it suddenly go out of sync? Is it because of this run of 1s? Yeah, the 1s process much faster than the 0s. Okay, interesting. So step, if it's going to wait for a value on the right, but there was nothing on the right. Oh, wait a minute. Doesn't jump equal to 0 have to use ACK? Yeah, it's based on oh no, because it's a label. That's what I'm supposed to be doing. That's correct. But why was it 0? Because I didn't think there was anything on the right. Maybe I missed it. Move up ACC. Jump equal to 0 right. How did it do that? There wasn't anything there. Move up ACC. Jump equal to 0 right. Oh, right. I'm stupid. We're not testing the right-hand side. We're saying, I've named these poorly. I've confused myself. We're testing this. If it's 0, then we choose right. So it's moving right down. But I think the assumption is that it will block until this output layer will block until we have 2 values for each one. I need to ensure that that's actually true. Move up ACC. So here's where we get the 3 that we're supposed to output. But wait, why would we be outputting 3 next? We should be outputting a 1 coming up soon, that one. So we're going to get a collision. Well, we've now got a 3 that's about to output, and this 1 is still waiting. Yeah, so this is not right. I either need to make it so that they always execute at the same speed, or I felt like they would execute at the same speed if they were always outputting numbers. Hang on, let's look at this. Step through it a bit slower. Same speed, because they're all zeros. All zeros. But we've got a 1 coming up. So these things have to execute 3 instructions: save, a move, and a jump. I'm wondering what would happen if I put a no-op in here. Just to balance things out a little bit. That's going to go unbalanced again. Wonder why. These get processed real fast. Oh, it's because of this. If there's no jump, we probably need another no-op in here. It's maybe a little better, but still bad. Maybe a little better, but still bad. Who is beeping me? Why are they beeps? I see no beeps. Discord's got this weird thing where it'll set off alarms even when you're not quite sure where they came from. Very strange. Hey, it's a real stream. Yes, and it was you making Discord noises. I'm so sorry that happened to you. That was terrible. But never mind. No, I wasn't kidnapped. I was not kidnapped at all. Except by sleep. I was kidnapped by sleep. Yeah, that was the longest stream I've ever done. 22 hours, man. 22 long hours. My throat was so sore by the end of it. Almost a 24-hour stream. I should have left it on, except OBS crashed. Excuse me. How are you? I hope you're doing well. You've obviously been to the gym, so that's good. Getting those gains. Right. So the thing is that column 4 is going to move way faster. Sat outside with a cup of tea. Very nice. The restorative tea. So it's almost like we should I don't know if slowing down with knobs is actually the right thing to do. I just don't know. Because it's like some of them will move way faster than others. So we've got column 1 with all of its 1s going far ahead. This one going far ahead. There doesn't seem to be a way to make them move in perfect sync. And for this approach to work, they've got to. Unless there's a way to... And of course, 1 and 4 don't block because they haven't got these pauses. Like there's much more code, many more instructions to execute in there than there are in there. So how do I sort that? I could put a bunch of no-ops in these blocks just to see if it would slow things down. It seems really artificial. It really doesn't help. Do no-ops not take up time? I thought they would take a cycle. No effect on the node's internal state or communication ports. Automatically converted to the instruction add null. Okay. Yeah. I don't know what to make of that. I really don't. Because it's supposed to take up a line, right? Like, if I step, I should see it stepping at the same time as all the other things. So... yeah. But the trouble is it's slowing it down no matter what, no matter if it's a 1 or a 0. I think that's the problem. So if this is so bad, if we go JEZ out, and then out is here, then that would in theory slow anything that wasn't a 0 down by 3 instructions. That's so bad. It does kind of work. But for some reason, the middle ones, in fact, maybe if I take all the no-ops out of the first instructions and just slow everything down. In the second layer, where I have more control over it. It's better. It's not perfect, but it's better. All right, so we'll add even more. Oh, I feel so guilty. This is ridiculous. And it doesn't affect the ones that are coming out of here, but let's just try it. No. No, no, no. No, this is not a sensible way to solve the problem. We need to think about it. We need to think about it. We're getting the right answer, but we've got a huge timing issue. So is there a way for the timing to take place in here? Can we block until we've seen 2 values? Until we've always seen 2 values, and then we decide which one we want to. Yeah, that would be a better approach. Oh, what Be This Dark Magic looks like assembly. It kind of is. It's a game called TIS-100, which is a Zachtronics game. I don't know if you've ever heard of Zachtronics. It's a really obscure game, and kind of an old one now. I'm trying to play a whole bunch of these games that I've had on my drive for ages and only half finished. So, and also because it's a really effective way to drive viewers away by playing a game that's based on assembly language. So you get given this manual, and the idea is that your uncle Randy has died, and someone has discovered one of his old computers, and he's left lots of cryptic notes inside the computer itself, but also you have to solve the puzzles using assembler in order to progress through the game. So it gives you like an instruction set, and you have to repair nodes within the computer in order to progress. So, for example, if you click on communication failure debug, that pops up with this little message, and gradually unveils more of the story. It's a really, really inventive game, and he went on to write a lot of other things, which I hope to finish too. Shenzhen IO was one of his. Space Chem is also a really good one. Yeah, it's just a super impressive game, but it's not easy to watch. it's, it's basically just me trying to figure out programming problems. But yeah, it's really cool. A really interesting idea. So at the moment, I'm trying to figure out, I'm getting the right answer, but I need everything to move. I need to not advance to the next row of numbers until I finish the previous one. And I'm struggling with that a little bit. So we need to wait before we move on. So move up ACC, save, move right ACC. Okay. So that means that we always get them in the same timing. And then we check if the one in ACC is greater than 0, so jump greater than 0 out. Otherwise, swap. And then jump greater than 0 out. And then mov 0 down. And then out is going to be mov ACC down. Yeah, I think that's right. So, and then this one is jump. Actually, we don't care if it's if we've hang on. I need to output if there's a positive value in one of those registers, I need to output it. Otherwise, I need to output 0. So I still need an output. I need to mov ACC down, but I don't need the second one of these. I can just go mov ACC down, jump begin. Or actually, I can just fall through like that. Ooh, that's elegant. I like that. I wonder if it'll work. It might be pretty, but if it doesn't work, there's no use to me. Are you going to get it? Oh, man. Oh, I'm fascinated to hear how you get on. It's not an expensive game by any means. It's been around for ages. I heard that Zachtronics stopped making games, which is kind of sad. But what today? But yeah, I think just kind of lost the drive to do it. Oh, you're going to get it today. Nice. Because they're really niche games. You know, you can imagine it might have been quite hard to achieve a lot of commercial success with them, but the fact that they're so popular, I think, is testament to how good they are. The other ones are really good too, like kind of almost a lot less unforgiving than this one, like Shenzhen IO. Space Chem is a really pretty game. And it's a similar sort of thing, but using chemicals. And I haven't played Infinifactory. I might have to get that. Shenzhen IO is really good. Build circuits, write code, RTFM. Okay, so this one needs to be more of left ACC. So the idea is going to be that they will block until they get both values. And then just move there. And then we need something very similar to merge both of the streams together. Okay, let's step through this and see where we get to. Okay, so 0 is correct, and they're all staying in sync mostly. Oh yeah, I have a good feeling about this. I think that's going to work. Let's try. Nope. Sorry about the loud noises. Damn. Oh, I was close there for a minute. Okay, so let's try and find the first failure. It's going a long way ahead here. So I'm guessing that this step isn't enough to sync it up. I thought that it would wait until it had everything. Move left, ACC. Jump greater than 0 out, swap. And then out, move ACC down. Why is this one so far ahead? Is it because of those ones? Oh, you've got it now. I don't understand why that one didn't block. I must have I've misunderstood something here. I wonder if... I wonder if I should actually mirror this up so that... this is just guesswork really, but... Let's copy this one over here. We're building up... It's like building a little integrated circuit here. Mov up right. And then this one is mov up right. So they both go right and then down. And then mov up left. And then this one is mov left, ACC, mov right, ACC. Yeah, so they both have to cover the same amount of distance. I don't know if that matters, but let's just try it. Okay. So it looks like this one lags behind now. So I don't understand. Why are they not blocking until they get 2 values? Huh. Getting a message. Oh. Apparently I'm seeing my partner a little sooner than I had expected tonight. All right, I might need to call it. Yeah, I do need to call it. Damn it. Yeah, sad to say. messaged. Better turn the desktop sound off. You can see this game consuming you. Don't get distracted. It's yeah, it's definitely. I'm trying to do a little bit every stream kind of thing. But yeah, it's a brain fuck for sure. And I think there are certain kind of people who will just 100% the whole thing really quickly, but I'm definitely not in that bracket. But it's quite satisfying when you get it right. So, all right. I need to go. Do you want to be rated anywhere? Who's on even? We've got Dylan. You can go and see Dylan. Jitspo. Yeah, let's go and see Dylan. You're going to drop off and play this? Fair enough. Thanks for checking in. Let me know how you get on with the game.